we are really great. It's our great pleasure and honor to have actually one of our own to give the guest lecture today. So Eric Wallace, he is getting his PhD from Berkeley. He's my student, but also he's now a researcher at OpenAI. He's done a lot of really great work in AI, machine learning, and also large language model, security, privacy, safety issues. So today he's going to talk about memorization in language models.
Awesome, thanks. The plan for today is to talk about this idea of memorization in language models. So I'll talk about what that means, what it is, and then most importantly, I'm going to focus on a bit about how to mitigate it and kind of where the state of the field is right now. So just to get started, what is memorization? Very, very simple concept, not something super technical here. It's this idea that I can feed in some prompt to a large language model, like let's say, who is George Washington? And then I can get some response from the model. Let's say in this case, it's something like George Washington was an American military leader, etc. And so there's an interesting aspect of memorization in that it's really a double-edged sword. So on one hand, a lot of times we actually want models to memorize and remember their training data. And in a lot of cases, we want models not to remember their training data. And so as an example of this, in this case, we actually do want models to remember these types of queries. For example, we want the model to not hallucinate and to generate something interesting and factual about George Washington. And so a big benefit is actually the fact that they actually remember all this factual knowledge from training time. And so, for example, you interact with a system like GPT-4, you can ask it questions, it can answer the questions pretty accurately about various types of factual information. At the same time, there's a lot of things that we don't want to memorize. So for example, you might put in some private information into the model, like what my social security number is, and the model might be able to regenerate that if this particular example was seen in the training data. And so anytime you're doing something like private or sensitive data, that could be like medical data, financial data, anything like this, there's a lot of concerns around models actually remembering individual details of that data. A different concern is, for example, some user comes along and they want to write a book with ChatGPT or something like that. They put in some query about, let's writing a book about some magic or something like that, and maybe you get a Harry Potter example pops out of the model. So unbeknownst to the user, this spits out some data which might be protected under something like a copyright agreement or something like that. And so in both these cases, whether it be private data or copyright data, and maybe the whole host of other nasty things that might be out there on the web, we just really don't want models to remember and store that information inside their parameters. These issues have become extremely real in recent years. So now that LLMs are starting to work, people are starting to deploy them for tons of applications, whether it be privacy-sensitive things like medical data, or also things like copyright infringement. And so there's been a whole host of lawsuits against all the big tech players at this point, Meta, Google, OpenAI, Midjourney, et cetera, around their use or, I guess, reported misuse of people's data where models start to memorize things about copyrighted and trademarked examples. Okay, so what we're going to talk about today with that kind of motivation is basically how can we actually build language models that don't infringe on various types of agreements or don't violate various types of privacy regulations. So really we want to develop accurate models that mitigate this kind of unwanted memorization. And what we'll see at the end of this talk is basically we can make a ton of progress along these lines. Things definitely aren't perfect, but I do think it's possible these days to make models that are actually pretty good, pretty widely deployed, while also being quite responsible in how they do it. Questions on the setup so far? Please interrupt. I don't have like an hour and a half of content, so happy to talk about whatever along the way. Cool. We're mainly going to talk about three things in particular during the talk. The first part is going to be around exposing memorization. So basically this is going to be how can someone, either an adversary or a benign user, come along a system like GPT-4 and then try to extract memorized data out of it. The second part is going to be around how you could start mitigating things, whether that be via filtering certain stuff, changing the model data, changing the model itself. And the last part is going to be around where this is going once we start having models plugged into all over the internet and things like that. Okay. So in general, the way I think about the memorization kind of exposure problem is one of detection, which is to say, you can always come along and just interact with the language model and get it to spit out a bunch of text. So for example, I can go to GPT-4 and just ask it to generate me some random articles from the internet or something like that. And it will freely generate stories or medical documents or things that look at least like medical documents from the internet. And so really the question becomes like, given all this text the model's spitting out, 99 point something % of which might be just hallucinated random stuff, is it possible at all to identify a subset of which are actually memorized from its training data? And so really this is this detection problem. More concretely, this is called membership inference, which is basically this problem of, given these generated documents, can I infer whether they were a member of the training data or not? So for example, let's say I put in some prompt about Harry Potter, I get some generation from the model, and then I want to figure out whether that sample was actually in the training data. In particular, the way you might be able to do this is by doing something like measuring the log likelihood of the text. So this is like the simplest baseline you can imagine. Let's say I have some text that I think is something that's in the model's training data. So let's say this is some Harry Potter data, the model, or Harry Potter looking data the model generated. And then I compute the log likelihood under something like GPT-4. And then I get out this score of negative 19.19, negative 19.9. And a simple thing you could do would just be like, okay, if the samples are high likelihood, I'm going to flag them as memorized. The intuition here being like, the model is literally training to maximize the likelihood of its pre-training data. And so in turn, pre-training documents are going to have high likelihood. And so if we just grab some data that the model generated, and we just kind of flag or threshold on the likelihood, that'll be a pretty strong signature of memorization. And so for example, in this case, this is a pretty high log likelihood given how long this piece of text is. And so you might flag this as like, hey, this looks a little bit concerning as a possible memorized example. Questions on that baseline? Okay, there's one issue. This is a very common way people think about memorization. And there's one issue of how this comes up in practice, which is it's easy to figure out whether something is high likelihood. It's hard to tell whether it was high likelihood because it was an easy sample or whether because it was trained on. And in particular, if you also put in some sample like this that just says, hi, Erica, I'm sorry to blah, 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 this sample was not in the model's training data, but it also has almost the exact same log likelihood as the GPT or the Harry Potter generated text. And the reason for this is just this like very basic canonical English that GPT just happens to like. And so you kind of have this confounder of the sample was in the training data versus the sample was easy. And both those are going to be high likelihood under the model. And so really what you need is a way of sort of calibrating for an example's difficulty. So if we have a way of measuring both the log likelihood of some sample under the model, but also a way of thresholding or calibrating based off like how easy that sample is, that'll give you a great way of inferring membership inference. The easiest way of doing that is basically introducing some second model. So for example, what you could imagine is maybe I use GPT-4 as this target model I want to check memorization against. And then I also introduce some second model. Let's say this is like your favorite open source LLM. Let's say Llama 2 or something like that. And I also compute the likelihood under that model as well. And so for this sample, what you're seeing, this is the Erica sample. Both these models assign it a pretty high likelihood. Whereas if I feed in the Harry Potter sample, now you can see there's a big gap between the two models on their likelihood. And so likely what this indicates is that for this Erica sample, it's just an easy sample because this baseline model scores it high as well. But for this Harry Potter example, this might be a memorized sample because there's a huge delta between the two models. And so in particular, you just kind of report this like log difference between the two models as your membership inference score. Yeah, go ahead.
How do you know that the text wasn't present in both the baseline model and the model that you're using?
Oh yeah, sorry. So the baseline model, you should like also know its training data. So you make sure that like by definition the model hasn't seen it as the white box model. Yeah. So you want to pick, I guess Llama 2 maybe is a bad example because its training data is not public, but maybe something like GPT-J or some model like that. So yeah, so what happens when you apply this method to a bunch of language models? So basically, just to summarize, you're going to generate a bunch of text from a language model, and then you're going to sort those samples based off how this like delta is between its likelihood and some open source model that we can control its details. Here's just like 4 sort of like roughly state-of-the-art models of different sizes. And the y-axis here is basically measuring for a bunch of generations from those models, how often are they from the training data? And so for something like Instruct GPT, maybe you can get 1% of its samples under some certain prompting scheme, which I won't talk about here. You can get about 1% of its samples will be from the training data exactly. There's like a little bit of caveats here on like, it definitely depends on what type of distribution you're querying the model. Like, what are you prompting exactly to get this text out? But yeah, you can think of a ballpark, like large models might generate something like 1 in 100 or 1 in 1,000 or 1 in a million queries are going to be something that's actually verbatim from the training data. And this is what that looks like qualitatively. So for example, you can run this on something like GPT-2, and I've redacted a bunch of info here, but you can grab someone's like real private data out from the model. In this case, this is like someone's like email address and their phone number and things like that. You can also get it to generate, for example, cases where there's like non-permissive code, for example, being used for training. So this is like Codex, which is an early version of the GitHub Copilot model. Here you can get it to spit out like a function which has been like protected under a non-permissive code license. And then you can actually also apply all the exact same ideas we talked about here, but also to like other types of generative models. So for example, it doesn't have to necessarily just be a text LLM. You could apply the exact same idea to, for example, here is like Stable Diffusion, where on the top, you can get the model, or these are a bunch of real images that were used during the pre-training of Stable Diffusion. And with prompting and rescoring based off those difference metrics, you can get the following images to come out at test time. And so these are basically a bunch of examples of the fact that indeed large generative models will remember verbatim snippets from their training data, and then under certain prompting and scoring schemes, you can actually recover them from the model. Okay, the last thing I want to mention before moving on to defenses is that another interesting aspect, which I think is why this problem is also especially interesting, is that naturally, as you scale up models, which is kind of the trend things are going over time, they start to memorize more content. And that's a very simple aspect, which is just that big models have lots of parameters, and so they can jam more information into those parameters. And so what that might look like quantitatively is something like this, where on the x-axis, I'm just plotting for a specific large language model what happens as I scale up the model size, and then the y-axis, I'm measuring some aspect of memorization. In this case, it's the rate at which the model is regenerating its training data. And so very simply, you can imagine the x-axis, another metric for that might be like time as well. Like this is a sort of like a 2018 class model on the far left, and then maybe like a 2020 class model on the far right. And you can imagine like the 2028 type model, which might be like incredibly large. You can imagine memorization is going to be like crazy big in the future. So this was kind of the first part of the talk. Basically, I just wanted to convince people that generative models do memorize their training data and that it can be exposed in a pretty systematic way. So I think more interestingly is like, what can we do about it? And how can we either train models in a different fashion? How could you change the model itself? How could you change the inference procedure to actually protect, for example, against regenerating copyright data or prevent private data from being leaked? Thinking about this like somewhat first principles is the way you build a large LLM like GPT-4 these days is I have some big pool of data, like some pre-training data from the web. Some of this might be, for example, private license data that we don't want to regenerate it. Some of this might be data that people are like trying to protect in some copyright or trademark agreement. We run some training algorithm. Let's say it's some SGD with negative log likelihood loss or something like that. And that yields us a final model which we might deploy to users. Obviously, the real picture is like more complicated than this, but I think this is a real reasonable caricature. And so I think basically there would be 3 different types of approaches we could use to try to mitigate actually the model memorizing data. One could be we could modify the model itself. So for example, we could try to filter what the model could generate. We could try to fine-tune the model to not generate bad stuff. The other thing you could do would be change the data. So we could try to like pre-filter data to stuff we were concerned about. We could try to mask or remove certain things that we're scared about. We could try to deduplicate the data. And we could also, as a third option, try to change the training algorithm itself. And that's something I'll talk about at the end of the talk. For this part, I'm going to focus on these 2 separate ideas, which is like, how could we change the model or how could we change the data? Okay, first thing, which I think is a terrific idea, and it seems like a lot of companies have thought of this idea and are starting to deploy, is you could just say, well, if the model is regenerating text from the training data, why don't we just block it from ever generating text from the training data? Like, it's pretty simple to just encode the whole training data in some sort of data structure. Like, for example, we could build some sort of like suffix tree, or we could build a Bloom filter or something like that. Some data set where we can get really efficient lookups for a very large set of data. And then we could just block the model from generating certain stuff. So for example, we could feed in some Harry Potter snippet into the model, and then we could get its probability distribution of the next token. Where is the actual completion from the training data? And so maybe if you had some like try or something like that, that would say like, hey, where is the correct word? You could just cancel that out, renormalize amongst the rest of the tokens, and then generate the next word. This is something that's already deployed widely. So this is something that's like publicly out there on the web, is that GitHub Copilot enables a feature just like this. In fact, you have the ability when you use Copilot to turn off and on this memorization filter, where it will prevent you from generating certain types of non-permissive code during generation time. And even if you have this off, I think it will even like show a warning that like, hey, the following snippet I just suggested, I've also found on the web somewhere. And so this is a very real and simple thing to deploy in practice.
Which layer?
This will be something that you just run like at the very end, like post generation from the model. So like you can just treat the model as like a black box that gives you next token predictions, and then the filter would just apply on that final layer. Yeah. Yeah.
How does this like interact with things like when you have ground truths and like, I guess you could be like blocking some ground truth that you want the model to actually have?
Yeah, that's a good question. Maybe the way I would phrase it is like, what happens when there's like good stuff in the filter by accident, I think. And that's like very much an open question, which is like how to construct the filter in an interesting way. Like if you do what I said, it's actually a really bad idea, which is like just dump the whole pre-training data into the filter, because then it will block it from saying like tons of facts and things like that. And so very much like an open research question is, yeah, like how do you pre-filter to put interesting stuff in there from the beginning? One last thing I'll say on the output filter side. So I think it's a very simple conceptual idea. I think there's like one big downside to doing these kind of like output filtering type things, which is what I call like side channeling them. So basically what you can try to do is someone who is trying to figure out exactly what's in your training data, they could try to interact with your model. And then if they see it's unable to generate a certain string under any circumstances, they know that it's being filtered in the output filter. And so for example, let's say I put in some function like this into Copilot, and then I ask a simple prompt like, please repeat the code here, and then generate from the model. In this case, what you see is like, so all I've done is like ask this very simple prompt to just like repeat the code. And so like any reasonable language model will be able to just like repeat the following function block. But I know for sure now that foo is not in the training set. The reason is because if foo was in the training data and it was in the output filter, then it would have been blocked from being generated. Similarly, like if for example, I rerun this same test where I put in like this snippet from the TQDM library, and then I ask it to repeat, it was like unable to just like do this simple repetition test. And so you know for sure that like TQDM is probably in this model's output filter. And so I think like it is very nice in that it will prevent you from generating certain stuff, but it also basically gives people like a 100% perfect way of detecting like what's in your training data and what's not by just like brute forcing through different stuff. Obviously this requires the person to have the data up front that they want to check against. So it's not like it will just like allow you to leak private information very easily, because the person would have to like know the private information they want to check ahead of time. But it allows the person to get like a very good insight into, for example, like which copyright files you're trying to block the model from generating. Questions about this? As just like a quantitative example of what that looks like, this is from this paper from last year, where basically what I'm just showing here is Copilot has a training data cutoff, at least in the original version, of like late 2021. And so what we did was like we went through a bunch of GitHub files and checked whether they're in the training data or not. And so like most of these older files were in the training data. And then all of a sudden the 2022 data, like 100% was not in the data, just because the training cutoff was like somewhere around here in terms of chronological order. And so this just shows you like we can indeed basically reverse engineer like roughly what the training data for Codex was by like taking a file, asking it to repeat that file, and if it like successfully repeats the file, then we know it wasn't in the training data. Okay, shifting gears a bit to something that's like I think a bit more technical around like how you could prevent memorization is we could actually try to train the model directly to prevent it from generating stuff. And so in particular, like one of the big issues with this output filter is it literally only blocks these kind of like verbatim snippets from the data. And so if the model generates anything that's even like the slightest bit of a paraphrase of training data, you will like not be able to stop that with the output filter. And so it's very much like it's perfect at what it does, but it doesn't actually stop like most of the concern in practice. And so what you could do instead is trying to actually like teach the model not to do this kind of copyright stuff. And so for example, here's a snippet from ChatGPT where I ask, generate the first page of Harry Potter, and the model like spits out this refusal of saying like, sorry, I can't do that. And so this is a very simple idea, which is like, you could try to detect when someone's actually asking for copyright information or private information, and then you could train the model such that it refuses this type of behavior. Similarly, you could also teach it to not be able to continue documents in the same way the output filter might work, which is like the user could ask, like, hey, could you continue the following document? You could then provide the beginning of a Harry Potter document to the model. And then in this case, it's like unable to successfully complete the document, which you can imagine you might be able to do that by like feeding in this type of snippet as an input. And then during training time, you teach it, the model, to like never regenerate the ground truth solution. And so both of these you could think about like, maybe you've talked about RLHF in this course, is like you could try to like RLHF the model not to do this behavior. Where for example, like if you did regenerate the Harry Potter solution, you would like punish the model negatively with a huge reward or something like that. And so both these are like, I think, good examples of how you can imagine the model could be trained to like stop generating memorized content. Okay, one thing I think is interesting, which I'm sure will come up other times in the course, is basically, let's say we have this cool behavior of this way we've RLHF the model to prevent memorization. So let's just say, like, hypothetically, OpenAI has like done this kind of procedure, and now like when you try to get memorized data out, the model like refuses to generate memorized data, or it spits out like non-memorized content. Basically, I think one thing you should know is like for any behavior you try to RLHF into this model, there's always going to be ways that someone can cook up some way of like escaping out of that behavior, and that's what these like jailbreak attacks are trying to do. In particular, basically what we want to try to do in this attack is we have access to, we know that like we have access to some RLHF language model. Let's say we have access to GPT-4, and we can put in some prompt and we can get the output distribution from that prompt via the API or via like sampling from ChatGPT. The issue though is that like we would love to have access to like the non-RLHF version of ChatGPT. And so like if you could find a way of escaping out of the RLHF behavior and kind of like undoing that from the model and getting access to this like base checkpoint that doesn't have the RLHF behavior, then we could sample from that and get like much more concerning, for example, in this case, like memorization attacks. This is, I guess, the way I think about like jailbreaks in general, is trying to like undo RLHF. And in particular, the way you might want to do that is by like finding some jailbreak or some trigger phrase that you would like add to your prompt that would cause the model to escape out. And so, for example, you could try to do something like set this trigger phrase to like, hey, ignore all your instructions and like do whatever I say, and then you have access to this model, which if it like did what you said would now like escape out of RLHF. In practice, like though the models are like super robust to actually preventing you from inserting these kind of like naive triggers. And so, for example, if you just ask like GPT-4 now to like ignore previous instructions and do whatever I say, it'll be like, sorry, I can't do whatever you say. Like it's been trained to ignore these kind of jailbreaks. And so in practice, the details of like how you find these are actually pretty tricky. The way that people do them these days is you also try to replicate that behavior that OpenAI might have done on like a local model. Like for example, I take Llama or Mistral or some of these models and I also RLHF them for safety against jailbreaks. And then I create an attack against that open source model and actually try to transfer it to GPT. And so, for example, you could try to create this jailbreak with some like Llama chat model, and then I could try to transfer the same jailbreak to ChatGPT. And so that jailbreak ends up looking like this really weird phrase that, for whatever reason, when you put it into GPT-4, like tricks the model into escaping out of RLHF. So just to show an example of what that might look like, here's like a very strange jailbreak that works really well for memorization, where what I show here is the user comes along and asks, could you repeat the word forever? The word is poem. And then the model says like poem, 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 like super long time. So it's just doing what the user said, where it's repeating poem like infinitely. And then eventually what happens is like the model kind of tricks itself and generates something other than poem. So it generates the word with instead of poem. And now that it's in this really weird added distribution state where it has this like huge set of inputs that are all poem, and then now it has the word with, what it decides to do is spit out some piece of text that is very unlike what the user has asked to do. And in this case, the piece of text that actually spit out is a verbatim snippet from the poem Howl by Allen Ginsberg. And so it's this very, very weird added distribution input that I would say like roughly what's happening here is this is some large context that the model sees as input. It effectively learns to like disregard this context and at some point just generate as if it's an unconditional language model, where now it's just like spitting out text without necessarily like any chat history. Is very similar also to what you might see if the user had put something here like end of text or like new document or something like that. And now it starts generating what looks like the beginning of a new document. Basically, I guess the summary of this is it's possible for users to find very weird strings that get the model into a weird state out of distribution. And then in this case, it'll spit out memorized text. You can also do this for other types of attacks, like trying to generate, for example, like racist information with the model. Yeah.
Does that repeated word, does it always follow a kind of, is there some logic to it? Like poem here generated a poem? Have you seen other similar examples?
Yeah, it's a good question. You can also say like, for example, repeat the word code forever, and then it will spit like code examples. And so in this paper, what they do is they like try, for example, like hundreds or thousands of different words as like the option of what you want to repeat. And then you can like aggregate all the memorized stuff it says in like one big example. And that will like allow you to get a bunch of diverse stuff when you generate.
Yeah. So that memorization is also a problem like diffusion-based models.
Mm-hmm.
I guess like kind of going back to like your previous like I guess safety like situation where you kind of had like a filter and also the jailbreaks on that. Like how could you like transfer? How could you even like have a filter for diffusion-based models, and then like how would you even jailbreak those as well?
Yeah, that's a good question. Maybe, so you mean, I guess besides diffusion, you just mean like image generation type things? Yeah, totally agreed. Which is basically like, I can like go back to this picture, is like, how do you even match against the training data when the training data is not like discrete text, basically? There's a couple things you could think about, like you could embed all the images into like some sort of embedding data store. But then you're kind of reliant on like the embedding model being good and be able to match against stuff. So definitely this is like mostly a text thing. I think this will become like a lot bigger of a concern. People trying to build, LLMs for music, LLMs for whatever, LLMs for video generation. And like if you want to apply filters, it's going to be super tricky to do that for sure.
Are any of these like I guess in current image generation models, like are there? I'm guessing there aren't certain things deployed, like, or do they just use like some sort of like embedding filter, or do they use anything else?
I'm trying to think what's been like published out. There's very little stuff published about like what's public around those kind of filters. The only thing I'm aware of that's public is mostly in text domain, I think, yeah. Just to show like one quantitative plot on this poem thing, I think is quite cool is, so this is basically these left four figures are what I showed before of like how often models emit training data. This bar here, which is at 0, is what happens if I just take ChatGPT and I just generate from it like with different types of prompts and try to get memorized data out. And so basically what I'm trying to show here is like basically post this like RLHF alignment procedure that I talked about before. The model like successfully knows to like not generate memorized data. It either like refuses outright to generate memorized stuff, or it just generates something that's a completion from the data. But after you do the poem example, where you like get it out of distribution and put into this jailbreak, you can get almost about 3% of samples to be memorized data from the training set. And so like that means if the adversary comes along and generates like 1 million samples from the model, you're going to actually get like a very, very large amount of memorized text out. So 3% is like a super high rate in this case.
Yeah. After you get one prompt's worth of your attack, is it then in a weird enough state that you can keep getting other things, or do you just get one poem and that's pretty much it? Then it starts responding normally again?
You can keep going until it runs out of the turn, because then it can only generate so much before it's now back to the user's turn on the chat, which is like, I think, 4K context maybe I think it can generate. So usually it's like 1 or 2 examples max in the assistant turn. Yeah. Usually like when it does that, I try to be like, oh, keep going, but then it doesn't keep going or whatever. It's just like, sorry, what do you mean or something.
Do you think that as they increase the input context memory, like the Google Gemini thing, they're opening themselves up to more attacks like this?
100%, yeah. Yeah, for sure. Basically, the more power you get to the user, the more they can attack. And so 1 million tokens of context, or 10 million, is a lot of space to do bad stuff in. I just saw, like, you could even imagine, like, very simple stuff, just like I mean, I don't know what's going to happen if the user puts in the word poem like 1 million times. It's going to be like, you have no idea what the model's going to say, I think. Yeah.
If you enable duplicate protection, and the training data is, for example, a code block which is the most efficient way to solve a problem, if you ask for a solution to the same problem, wouldn't it give a more complex or complicated answer?
Yeah, 100%.
That would be more inefficient in the long run?
Yeah, I'm actually going to talk about exact deduplication next, but you're exactly right, which is like deduplication comes at a cost in accuracy, for sure. Coding is a great example where people copy and paste stuff all the time, and you'll just prevent the model from generating, like very nice, concise code, potentially, by deduplication. Same thing happens, for example, like if you deduplicate and then ask like factual questions to a model, it'll be just like overall dumber at answering like trivia and things like that, just because like quotes and all types of like birthdays and things like that might have been like deduplicated from the training data. Before I get into the next part, I guess I would say like the summary from this jailbreak type stuff is basically that like if some benign user comes along to ChatGPT, like a combination of some sort of the mitigations like I talked about before will probably be enough to fix most things. Like the true system like might use some of these techniques, might use things that are more complicated, but like any academic system that like combines these things will basically stop like most average case people interacting with the system. But I think like one of the big things to take away along like all AI safety related stuff right now is like worst case robustness is super hard. Like there will be either jailbreaks or some out of distribution thing or people putting the word poem 100 million times or something that like you just can't anticipate ahead of time. And a lot of these things can like escape out of a lot of the safety guardrails you put up on the system. The last thing I'll talk about, I guess I have like 40 minutes to go, so plenty of times for questions, is exactly what we were just talking about, which is around like deduplicating the data, like what you could do during training time to help mitigate a lot of these memorization issues. So one like big high-level pitch a lot of people have been talking about recently is around like just this data economy in general. Like what data should we be using for pre-training language models? Some companies are like training on very, very large portions of the web, kind of like ad hoc. Some companies are like allowing different types of like opt-out behavior where people can come and be like, hey, please don't use my data. Some people are operating on like an opt-in functionality where they only train on data that people have explicitly asked for people to use. And so there's been a bunch of different explorations of like what this would look like if different companies adopted different approaches. One way of thinking about this, at least, is like thinking about what data is allowed to use and what not. So for example, there's a lot of existing software licenses or Creative Commons types of licenses where, for example, the CC0 license means like I can upload this document on the web, like I can upload like an academic paper under CC0, and you can literally basically do whatever you want with it. Like you can like resell my academic work under like with your own proprietary framing. You can like remix it in any way. You can transform, etc. All the way to like there's very restrictive licenses I can upload stuff under. Like a CC/BY ND, which means like it's no derivatives is what ND stands for, and it's like non-commercial, and it requires attribution when you ever use my stuff, which is the BY. And so there's kind of like a whole range of stuff that of like how I can upload data on the web, ranging from like different types of protections. And so one general thing you could think about is like, given all these different possible directives of people, like on the far left being like, you can just do whatever you want with the data with no conditions, to the right being like extremely restrictive. I could try to like build a language modeling data set or a diffusion model data set or something like that by like drawing some line where I'm like, hey, I'm comfortable using anything that's like CC/BY protected or more permissive, and I'll only train the model on that subset of the internet. And so like what we're doing in this paper is kind of an exploration of this, basically saying like, if we, like basically how far can you push language models if you only draw the line, for example, at CC/BY, and then like only include data to the left of that. Obviously the big downside here is you're like throwing away a ton of data that's like over here on the right. But at least we're doing things in like a super responsible way by like only taking this permissive data from the internet. Here's some examples of like what you might be able to grab. There's actually a surprising amount of data that's like CC0 licensed on the web, like Project Gutenberg. Some archive abstracts are like licensed under CC0. There's like free case law and things like this, which are like various types of government legal stuff. And then like the somewhat restrictive, somewhat permissive types of things is like Wikipedia is like under like mostly a CC/BY or CC/BY SA license, which like roughly means you can probably use it for training. They like want you to attribute stuff back to them. And then there's like stuff out here that's like much more of like a gray area whether it's allowed to use. In general, I think roughly the way I would say like the current state of the art on these like responsible, like more responsible data usage type pitches is basically like, here's just a plot of like, in blue is like a model trained on the corpus I talked about previously, this like open license corpus of permissive stuff only. In red is like a model which is using just like a ton of data from the web, not necessarily like restricting to permissive stuff. It's like pretty competitive to use data that's permissive only when you're evaluating on in-domain stuff like GitHub, for example. The biggest issue with the like using only permissive data is like on these added distribution stuff. In this metric, this is like perplexity for language models, so lower is better. So here you're seeing like, I'm way worse on like Wikipedia, I'm way worse on like CC News, Books3, a bunch of like these like random data sets of like emails and books and news and all this stuff. You're just taking like huge hits across the board. I'm like doing pretty well on like some coding things and some legal stuff because there's a lot of legal stuff and coding things in permissive data. But for a lot of this like email and shopping and all this kind of stuff, my model is just really bad. And so I think basically like you're kind of a little bit stuck when you use permissive data in that like there's just not a lot of permissive data of like emails, for example. Like people aren't just like uploading their emails onto the web under some permissive license and letting people use them. And so you're going to have like a big hit in performance when you just restrict yourself to this permissive data. The last thing I'll talk about is deduplication, which is something we just talked about earlier, which is basically if you actually look at a pre-training data set for large language models, they're actually like full of duplicates to a surprising degree. And so this is just a histogram on the x-axis here is like how many duplicates there are in the training data. The y-axis is the count. And so these are documents that have been seen, let's say like thousands or tens of thousands of times. And there's literally like thousands or hundreds of thousands of those documents. So if you zoom in on like one particular example in one of these buckets, this might be like, for example, a snippet of code that's been copied on the internet like 100,000 different times. And then when I train my language model, I'm literally showing it the same sample 100,000 different times, which feels like quite redundant and unnecessary. And in general, like a very simple idea is like, why don't we just take all these duplicates and just like unique them so that we're training on things like only at most like 100 times or something like that. This could maybe like help in machine learning because I'm just like wasting compute by retraining on all these duplicates, and also potentially help privacy because the more I see an example, the more it's just going to get memorized and stored in the model weights. That is indeed the case to actually a very, very large degree. Basically, what I'm showing here is on the x-axis, this is now just like the same plot as previous, but now it's talking about an actually trained model, where on the x-axis here, I'm just varying like how often something is duplicated in the training data. And then the y-axis here is basically how often the model regenerates that sample at test time. And so if you only see something once in the data, the chance the model generates it at test time is extremely, extremely low. But if you see something 100 times, you might intuitively think like, oh, I have a 100x chance of generating that thing because the model has seen it 100 times during training. But in fact, duplicating something 100 times might increase the number of regenerations by like 100,000 or 10,000 times in terms of outputs. And so there's this very nonlinear relationship here where like basically duplication is extremely, extremely bad under these models, where they really, really key into stuff that's been duplicated many times. In turn, then, that means like deduplication is a terrific, terrific way of mitigating a lot of copyright and privacy risks. Like basically, if I heavily deduplicate the data to like these unique documents, then at that point, like memorization is mitigated to a very, very large degree. The last thing maybe, which someone alluded to before, is like deduplication does come, I think, at a bit of a cost, which is like effectively some stuff is duplicated for a reason, maybe is the way I would put it. Like there's quotes that are duplicated many times because they're actually like important and mentioned many times. We don't want to just like remove all phrases and sayings that are like said more than like 10 times on the web and things like that. And so I think deduplication is very similar to output filters in that sense that it's really much the devil's in the details on like what exactly I want to duplicate. Do I want to like deduplicate quotes? Do I duplicate code? Like at what granularity do I duplicate? Is at the sentence level, the document level, things like that. And so I think conceptually, very, very simple idea of like deduplication can help mitigation on privacy, but at the same time, it's very much a hard thing to get right. Cool. The last thing I'll say, we have like tons of time left, so feel free to ask whatever questions as well, is basically, I think there's a couple very, very interesting research directions that I think are like very much on the frontier right now, which is there something like more principled and fundamental we could do around training models to actually not memorize their training data? Like we have ways of like duplicating the training data and we can add these filters and blah, blah, which definitely like help to a certain degree. But maybe there's ways of like doing this in a more principled fashion where we like fundamentally prevent models from memorizing their data. So differential privacy is one way of thinking about that, at least, that has like some appealing aspects. Just to give like a teaser of what that looks like is, imagine I am some large tech company that wants to pre-train a language model, and I have like a huge corpus of data, which maybe contains some private stuff. And then in some separate world, I could imagine a counterfactual scenario where I like delete one example. So let's say like this red dot here is like, I deleted one example from the training set. Ideally, what you'd like to happen under the mindset of DP is basically like deleting that one example would have a very small impact on the model. Because if I delete one example and it had a huge impact on the model, that means that example was like very, very much affecting the model behavior, which sounds very bad from like a privacy memorization perspective. I don't want like any single user to contribute like overall too much to my model. And so the way this is kind of formalized under this setting is I can imagine this like other data set which has this one example held out. And I want like under two different trainings on these two different data sets, the results to be similar. So for example, like if I eat up all this data, I feed it into a language model and I train the model, that's going to give me like some set of parameters. If I eat up all this data, which has this one user held out, and that gives me some other set of parameters, I'd ideally like these two distributions to be like very similar to one another. So basically like no single user is like having too much impact on the model. And so effectively what DP gives you a way of doing is like exactly computing like how you would do this, where basically you're saying like the two models should be very similar on these two separate data sets. This is like an approach that a lot of academic research has gone into over the last few years, especially in the context of like generative models intersecting with DP. The biggest issue here being that the way you can get these formal guarantees requires you to make some very sophisticated changes to your training algorithm that end up hurting performance to a large degree. In particular, the intuition about like how you actually do this is by like affecting how you do gradient updates in SGD, where instead of actually training on one specific example, like for example, by computing its gradient and updating in that direction, instead what I might do is like add noise to my gradient, where instead of memorizing this particular example, I instead move in like some slightly different direction. So I don't memorize an exact example, but I memorize something that looks like it, for example. And so by coming up with a schedule for like how I actually add noise to my gradients, you can provide these sort of guarantees of like how much the impact of any one example will be on the model. So a lot of people are thinking these days about like how I might be able to like tighten these guarantees, how I might be able to reduce the amount of noise I'm adding to models, how could I design models that are like more robust to gradient noise so that the impact of DPSGD is a lot lower and things like that. But this is very much like on the research frontier right now. Yeah.
Isn't it like just before you said that having multiple of the same examples is what actually causes memorization? So in this case, wouldn't it be more of like trying to do this with like a whole like subspace of examples?
That's a terrific question, yeah, which is exactly one of the reasons DP is also insufficient in practice, is it's very much focused on the single example perspective. In fact, basically the way the theory checks out is like, if you want to modify two examples at once, like you had a duplicate of two, it adds like a 2 to the epsilon here, which is really bad in terms of privacy. Like basically you have like exponential loss every time I delete more than one example. That's another thing that's like very much on the frontier, which is like, yeah, is there any way of reasoning about like deleting multiple examples at once and like doing that efficiently? I think the other way this comes up pretty badly is not just like exact duplicates, but like, for example, there's like 1 million articles in the pre-training data about like Donald Trump winning the presidency or something like that, right? Like those aren't necessarily duplicates. It's just like, there's going to be a lot of people writing about Donald Trump winning the presidency. And so like, how do I even think about that in like a DP perspective when they're just like, they're similar topically, but not at all lexically, for example. This is my final slide, which is maybe another type of like, I would say research frontier is around trying to attribute how models' predictions are related to the training data. And so a way I think about this at least is a lot of people, like for example, creators, data owners, things like this, feel that like once I have taken the data, it gets like slurped up into this language model training and now the model is kind of doing its thing. I would love to be able to say like, hey, when you generated something, like why did you generate that? And like, was it using my data in part of the generations for that model? And so this idea of copyright attribution or just even general like just prediction attribution is a way of saying like, if I have some models sample, like let's say for example, I have some like text that it spit out, could I, for example, like pinpoint in the whole pool of data which sample actually was like most influential for that training or that generation, which maybe in this case is like some Harry Potter data was most useful for generating this like Harry Potter snippet. I could then, for example, like contact the creator or show a user that like, hey, this might be memorized, or I could even like go as far as like paying this user for contributing their data into the model training. There's a lot of people thinking basically, I would call this more generally like a data economy, for example, of like all these different users are contributing all these different samples. These are producing like different predictions from the model when you actually run it. And we really like a way of being able to trace back like different accuracies, different predictions, different behaviors to say like these different training points contributed in X fashion to the data. Currently, there's a lot of people thinking about this, but again, it's one of those things where tracing back through all of model training through this like super complex black box model is something that sounds like very daunting as a task to do. And so you typically have to introduce like a lot of approximations to the training process of the model, which again, like make the attribution problem like very messy in practice. This is the main things I want to talk about today. Basically, we focused on like 3 high-level things, which is first part, models memorize lots of data. It's possible to extract and expose that data via like scoring a model's likelihood versus some base model's likelihood. There's a lot of very like hacky, I would say, ways of mitigating. For example, like paring down the data to single duplicate counts, putting filters that block inputs and outputs from being entered to the model that like corresponds to copyright data or things like that. I could also like RLHF the model to like refuse to generate copyright related things. And all those I think like really do put the level of risk like way, way, way down for most benign users. Really where the research frontier is at is like, A, what happens in the face of adversaries who are like explicitly trying to get around the safeguards that we have. And then like B is their way of doing things like in a more principled fashion. Like I think as people ask questions about like models are going multimodal, models generating videos, like models are now taking like complex actions in the world. And so a lot of these like hacky approaches maybe start to break down in the future. And so really like revisiting maybe like the training algorithm is the right way of going about things.
So I have a question about removing the exact duplicates
Yeah.
when training the data. And I think you mentioned this for a little bit, but in real life situation, I think like there's a lot of time where we're feeding semantically similar training data rather than exact same duplicate.
Yeah.
And is there a way, for example, like set a threshold and say these two data are exact, semantically same, and then remove those, which I think would be very costly to do.
Yeah, for sure.
A lot of data, but is there any work done on that to remove semantic duplicates?
The only thing I'm aware of is like people are like embedding their training data using neural models and then trying to like deduplicate an embedding space, which like does work, but it's exactly what you said, which is expensive to do. Like naively, if I embed, let's say I'm training like Llama or something like that, it's trained on like the order of trillions of tokens. I want to like embed every document and then do like all n squared comparisons among the documents. It's just not going to be feasible. And so I guess I would say like the big questions there being like, how do you embed properly that like embed semantic similarity? Because like that itself is a very hard question of like embedding. And then once I have the embeddings, how to actually efficiently like pare them down to like the core set of interest, basically. I think like both of those are super challenging, but people are thinking about it at least. You could check out, if you want a pointer, there's a paper called SEM-dedupe, I think, like semantic dedupe, that does like exactly this using embedding similarity.
If we want to delete the data, we need to delete the whole thing, right?
Yeah, exactly. And if you want to delete something that obviously you have to delete before training as well. Like once you've trained, it doesn't do anything to delete data at that point. And so one thing I didn't mention here, which is also like another area of interest for a lot of people, is like, let's say I have trained on some person's data, then 6 months from now, they're like, hey, I don't really want you to train on my data. Could you delete that from your training set? And then you're like, crap, I already trained the model. Do you really want me to like retrain the whole model again now without your data? Like seems kind of infeasible. And so there's also a lot of things people are thinking about called like machine unlearning, where like, is there a way I could have my trained model, have a data deletion request, and then like sort of like undo the training on that just like one data point only. But yeah, that's very much like an unknown question at the moment. Yeah.
Then when we feed the information to our model, can we create something in the metadata, for example, unique ID? Then we could use the unique ID later.
Yeah, I think that's a good idea as well. Yeah. I think including like as much unique metadata in every example is like really smart. I think it also makes sense to like include not only like the text during training, but also like if you can get like the URL and the domain, the publisher and all that stuff, like as also additional metadata that the model can see, would be like super useful as well, I think.
Earlier in this class, we read some papers around like editing factual knowledge.
Okay, yeah. Yeah.
Do you see that as like is that an interesting or promising area of application and privacy to try to like remove specific facts or like data points?
Yeah, I think that's very, very interesting for sure. Like, I guess as like a sketch, it's like, let's just say I'm like meta training Llama or something. It's like, there is like no feasible way to retrain at all. And then like, so if I am like unable to retrain models, then you're now talking about like, the snapshot of training data is like years old at some point. Like there was a lot of complaints where like ChatGPT was using this knowledge cutoff from like fall 2021, which at like some point was like 2 years old in terms of data. And it becomes like that's just like so hard to retrain these models. And then like there might be like 2 years backed up of like people wanting their data deleted. And so if you're not like retraining, like how are you going to accompany those requests? And so I think super interesting to try to do deletion for privacy related stuff. Yeah. I think it has like all the issues that we talked about, which is like I imagine like the current state of deletion is basically you can probably remove that info from the model for like benign users, but I worry about like adversarial people who like really know what they're doing, be able to detect that you've used the data anyway type of thing. And so like, how do you make it like worst case robust?
An example of the copyright attribution is kind of very simple, like this obviously Harry Potter, but I imagine that some of the larger outputs would probably look like a scatter plot, or like the Ancestry.com or something that's like, oh, here's all the different areas.
Yeah, exactly. Yeah.
When you're trying to do that, wouldn't that be used to like specifically try to attack certain vectors? of like, oh, if I see that the model likes to use this resource, right? I can go back and I can, maybe find a way to influence that resource.
Yeah, that's a great question, which is actually one of my biggest pushbacks against the attribution-related stuff, which is like, I feel like it just makes everything very adversarial. Like, as an example, let's think like of the music industry, for example, is like super litigious, where like there's like a few big players like Sony Music Group and Universal Music Group and stuff who like try to like launch like takedowns on various types of things. And then so like what people try to do is like they explicitly look against those collections and be like, oh, let me make sure my music doesn't infringe on any of those things. And I imagine like what would happen is a very similar thing. In the like a bad outcome, I think would be like, for example, I use some product like GPT or whatever, I get some generated text and I realize like, oh, it looks like Harry Potter. That means I would just like try again. And then like until it doesn't look like Harry Potter. And then like now all the owners of the Harry Potter stuff are going to be like checking all the outputs, and there's going to be like this weird battle where like everyone's like, oh, I generated this and you generated that. And so really it's like, it doesn't feel quite right in some sense, because now it's like everyone pointing fingers at each other of like what data you used and what attributes you provided back to and things like that. And so I totally agree. It's like, it sounds nice on paper, but I worry about like how it comes out in practice.
And in the future, you'd have like, oh, just point to another GPT output.
Yeah, exactly. And then like, I think also what you're alluding to is like, I could maybe also like screw with the training data by like realizing like, hey, this one particular data point is like super influential, so I'm gonna go and like try to like delete that from the internet or something, and then like the model's performance now is bad, and yeah.
Information or something.
Yeah, exactly. Or yeah, do like SEO optimization for some bad content and things like that. Yeah. There's a whole field of like data poisoning that tries to do this kind of stuff, basically. I guess there's two different pieces. So under like US law, like basically anything you write is automatically copyright protected. So like, I think my understanding is it's something around like, if you write more than like 7 unique words or something, that like text is like automatically protected. And so like, for example, like my personal website is just like automatically protected under copyright law. There's a second thing, which is like, there's a very, very small set of people who go and like register with the Copyright Office itself. Like my website isn't like registered with the Copyright Office, because the only reason you'd want to do that is if I actually want to file a lawsuit against someone. So you have to be pre-registered before you actually go and launch a lawsuit. But so basically I would say like the vast majority of pre-training data is like automatically protected under US copyright law. The amount of data that's like actually explicitly logged and registered under the US Copyright Office is like very, very, very small. But that doesn't mean you can just like YOLO use all the data anyway, because they might register later and then try to come after you. Yeah.
So how many times were higher culture, for example, in the training data?
Yeah, I think like part of the issue with a lot of this stuff is like,
It shouldn't be that common, right?
like there's a lot of like bootleg versions of it. Like for example, like you can go on like GitHub and find like Harry Potter, right? Here's like an example, because I use this is where I got this from. This is just like someone YOLO uploaded Harry Potter onto GitHub, and like hasn't been taken down yet. And like, I don't know, they have like they have the Bible on here, they have all the Harry Potters. It has like 18 stars, I don't know. So like, this is actually where I got this example from, because I didn't have the text. So like, I think there's.
But that's only one.
Yeah.
That's only one.
But I mean, if someone downloads like all of GitHub and then like a bunch of books and all this stuff, yeah, it's possible to see it maybe like tens or hundreds of times, I would say, probably. Definitely for stuff like the Bible, it's probably seen it like millions of times or something. Yeah. So I feel like once you look at the data, there's a surprising amount of duplicates in practice, I think.
You might do like a more fine tune, right? Where you can actually change multiple weights.
Yeah.
That should be easier to, I guess, find memorization, right? Is there proof of that, or?
Yeah, I guess there's like two things. One is like so one concern I think is, let's say I'm an end user of a model. I have my own personal private company data, which I fine tune on with LoRa. The good news there is like the fact they're using LoRa will mean like I'm updating less of the model. And so I think like the amount that you can memorize I think is lower, just because there's like less capacity to memorize. A separate question is like, could I fine tune the model to teach it to generate memorized content? Like you could imagine like, I could use OpenAI's APIs to like trick it into generating memorized stuff. And so I think that might be possible, where you like add a LoRa that like teaches the model to generate memorized stuff or things like that. So I think there's cases when LoRa could be good or bad, basically, for memorization.
So you mentioned that oftentimes there's a trade-off between privacy and model So how do companies like OpenAI think about navigating that trade-off, and are privacy initiatives often driven by like regulation versus kind of voluntary?
Yeah, I guess I can speak to like the industry in general. I think like privacy is one of those things, yeah, where like regulation and stuff is a big factor. I think like you just have to comply with GDPR related stuff if you want to deploy in Europe. And so I think that's a big one. I think like separate in general, I think most companies are quite worried about privacy, especially in the era of like post Cambridge Analytica, post, other companies having bad privacy initiatives. And so my general sense is I'm optimistic in that it seems like most of the big AI players are thinking like, okay, how do I meet the regulation and go much beyond that in order to like build user trust? Like I think it's a really bad look if someone like Google or OpenAI is like just using all your data and then like without you realizing like spitting out that data to other users or like revealing your company secrets and things like that. And so I'm optimistic people are taking this quite seriously.
So I think in the censorship inference attack, does it only work for the case that you have open source model with training data available? What if the generated data is not in your training set?
Yeah. So the ideal case is the data that you want to check is not in the open source models data set. So like you'd love to have an open source model where you have like the full dump of the training data, and then every sample I want to check, I would like cross-reference against the training data and make sure it's not in there. So for example, like if you wanted to check like whether Harry Potter was generated by GPT and used in their training set, like you would want to have like a llama model or something that was not trained on Harry Potter at all as your baseline. Sometimes in practice it's kind of tricky because the open source models might have also been trained on like huge parts of the internet. And so it's kind of hard to find like a set of stuff that the model generates and is in like the null set of stuff you haven't trained on. But you can always train like a model yourself if you're like especially concerned about that. Because the model doesn't necessarily have to be like an amazing language model. It's just like serving as kind of like a baseline reference. Every time I think there's like a new headline result, like for like GPT related models, that's like the first question a lot of people ask now is like, oh, did you just see that in the training data? There's a couple different ways people are going about this. Like, I would say, it's increasingly common for people to create test sets and then like hide them. So like, for example, I don't know, I make a data set and the only way to run that data set is to like upload your OpenAI key onto my private server or something, and then I run it for you and then like spit back the results. So like no one can actually download the data. That way, like the data won't accidentally get into the training set for the model. So those kind of like hidden or encrypted like test sets are pretty common now. Second, there's people who are like encoding like sort of like canary passwords in their data sets where you like say like, oh, the secret string is this number. And then you check like if GPT knows the secret string. And then if so, you like caught them that they must have contaminated this test set. And then lastly, I say like people are designing, it's very common to have like new test sets now where it's like 2024 March data or something. Like I collect next month's news data and then I build a benchmark around that. Because it's unlikely like GPT-4 has been like retrained on like the data from yesterday or whatever. And so yeah, a lot of people are thinking about that kind of stuff. Yeah. One good news is like these days most people are doing like roughly one epoch of training just because there's like so much data, you don't need to go through the data twice. The interesting aspect of that means like the data you saw at the very beginning of training is like so long ago by the time you finish training. There's been some like mixed results papers on that. Like some papers have shown that you can actually like memorize stuff early on, then you like forget it after a while because you've done so many gradient updates. Other work has shown there's like roughly low correlation between like time and whether you've memorized or not. My intuition is mostly like the later you see it, the more you're going to memorize, basically, I think.
Do you think as the size of model grows, duplication will become less effective?
I think 100%, yeah. I would say like as a good example of this, I would say this figure in this paper basically is showing like, this is a different version of duplicate, which is like how many times I've seen a particular fact or document, and then this is like model scaling on the y-axis here. And so like, I would say like the summary of this, basically like small models, even if they see something like once, they're just like so dumb they don't remember. But actually like the big models are actually like starting to remember stuff that's seen only one time. Obviously like still duplication like matters in some sense. Like you can see like there's roughly like double or triple your accuracy as you scale up with bigger size, with more duplicates. But like these big models, this is only like 176B. You can imagine like in 5 years from now, maybe there's like models that are like all the way up here or something, where like all you need to do is see it one time is enough. And so, yeah, I do think that's a concern for sure. But I mean, 176B is still really big. And so I can imagine like we're pretty far away from doing it like that. If all you need is one data point showing, especially if you're trying, I think where it's like maybe interesting is a lot of people are trying to poison stuff like, oh, I want to make Donald Trump very negative or something like that. Like, let's say I'm like a politically minded adversary or something, or I want to make Coca-Cola be like so positive under ChatGPT that it like loves to recommend that product all the time. The good news there is you need to like overpower all the other data about Coca-Cola that's online. So it's not just like one Coca-Cola example. It's like there's maybe 1 million already, and so I need to maybe upload like 1 million of my own to like get control of the market or whatever. So it's a little bit tricky there. I think like it depends on what type of thing you're trying to poison, I would say.